Hello everyone. In this session of CCNA series, I will discuss access control list and its concepts. An ACL is a fundamental concept in network security used to control the flow of traffic within a network. One of the two major reasons to use ACL in Cisco network is to either to filter the traffic going through the router or a switch or traffic to and from the device. And the other reason is to classify traffic for access to services or to trigger an event. It includes a list of statements that are meant to either permit or deny the movement of data. So when using an access list to filter traffic, a permit statement is used to allow traffic while deny statement is used to block the traffic. Similarly, when using an access list to identify traffic, a permit statement is used to include traffic, while a deny statement states that traffic should not be included. It is thus interpreted as true or false statement. ACL uses first match logic. So once a packet matches one line in the ACL, the router takes the action listed in that line of the ACL and stops looking further in the ACL. Once a match is made, the packet is either permitted or denied. There is an implicit deny all at the end of all access lists by default that prevents all traffic. So ACL filters identify network traffic based on IP addresses or protocols and ports. For example, let's take an example of an ACL, okay, where it denies host 192.168.1.0 any telnet traffic. From host, if you have any telnet traffic going to any destination, it will drop it. So filtering traffic is the primary use of the access list, as I discussed earlier, right? So here, if you see, I'm using IP address range 192.168.1.0. That means the source in that range, and then I'm using protocol TCP, and then telnet port number. So this is just an example. Okay, this is an example of the extended access list actually, which we will discuss about different types of access lists in the next video. So as I said, filtering traffic is a primary use of access list. There are several instances when it is necessary to identify traffic using ACLs. Okay, such as for identifying or matching packets for QoS. For example, voice packets can be prioritized as it requires less delay, less delay, right? So as I said, voice packets are prioritized because any drops in the voice packet will have an effect on your call. The next one is identifying traffic for NAT. Network address translation need to know which traffic should be translated from one IP to another. So it is used there as well. Then we have identifying traffic for encryption using VPN. So VPN tunnel uses ACLs to know which traffic should be encrypted or decrypted. So let's look at where the ACLs are placed and in which direction are they directed. So ACL can be configured to apply an inbound traffic where the packets enters the router and outbound traffic where the packet leaves the router. You should make a note that ACL does not act on packet that originate from the router itself. You have to make sure this, because if you apply the ACL and if the traffic is generated from your own router, then it will not be effective. That means we can decide to apply an access control list before we make a routing decision or after. So we must enable the access control list on each router interface that processes a packet and in the same direction that the packet travels. For example, imagine that you want to forward packet from host A to server 1 here. but you want to discard packets sent by host B to server 1. Like this, it should allow, and then it should stop it. So the arrowed line is the location and direction at which a router could apply an ACL, like interfaces FA0/0 on R1, S triple slash 0 on R1, that is outbound, and inbound S001, and then outbound is F00. In short, to filter a packet, you must enable an ACL on an interface that processes the packet, and in the same direction the packet flows through the interface. That's it for this session. I hope this was informative for you. Thank